Ah, the sun feels so nice today.
What if I told you that we're only decades away from being able to harness its power on Earth? The sun shines by fusing hydrogen into helium in its core. If we can recreate that process on Earth, we would have access to a source of clean and limitless energy. To explain how smashing atoms together makes power, let's first look at E equals mc squared, which correlates energy and mass together. In short, it's possible to turn a little bit of mass into a lot of energy. As an example, here are the nuclei of deuterium and tritium. They're currently the most promising candidates for harnessing fusion on Earth. They'll combine to form a helium-4 nucleus and the lone neutron. As you can see, the end result weighs less than the original nuclei, and that missing mass has been converted into harnessable energy. So why are the two masses different? You see, protons and neutrons are kind of like my friends playing badminton. Similarly to how they hit the birdie back and forth, nucleons exchange particles called pions, which are made of 2 quarks instead of the usual 3. The process is fairly complicated, but in short, it creates an attraction between the protons and neutrons, called the strong nuclear force. You can think of it like my friends who prefer to play with a partner, which allows them to save energy, preventing this from happening. For particles, the exact strength of the strong nuclear force is known as the binding energy. But remember, according to conservation of energy, everything has a price, so a part of the nucleus's mass needs to be converted into that force. And this is why fusing light atoms can make power. Different types of nuclei have different binding energies, and so that lost mass shows up again as usable power. And not only does it make a lot of it, it's also green and sustainable, which means that once we get over a few hurdles, nuclear fusion will change the world.